Okay, so before we get started on this topic, I want to give a little bit of lay of the land. And what I mean by this is how I view a web application and where things should happen. So if you imagine above these layers is the endpoint, and below these layers is the database. And so just when you're trying to get an organization all on the same page and writing code the same way and all these things, sometimes letting people know where you're expecting certain behaviors to live is helpful. And so when I'm looking at this, I want to look in particular at errors with status code, whether or not they're going to return an HTTP status code or not. And I would say if it's coming from the web layer, sure, add your HTTP status code. But if it's coming from back further than that, I'm looking for a generic error that the web layer will translate. And this might seem like a really basic thing to put in here, but what it does is allows developers to know where to put, what kind of errors to put where, without really having to make too many decisions about it. And you end up with a more consistent code base. You also have reasons why you make decisions like this, reasons that you can discuss with other developers, and so they can understand your thinking about where you're placing things. I also want to call attention to the orchestration piece here. There's two types of orchestration that I have listed here. The first type is more of a traffic cop orchestration. This is directing things where to go. So you can imagine a request comes in and we're going to direct it, oh, you have to go to this place. Sometimes during that type of orchestration, the cop is going to check your driver's license or run your license plate, do things like that, but all of it is in aims of directing you to the right place to go. The other type of orchestration that you have will be coordinating or doing the work. So this will be when you're taking things apart, putting them together, updating them, changing them, whatever you have to do. When you're actually doing the things that you have to do, I call that orchestration. So in the grand scheme of things, where this talk fits in is I'm talking about tools that we can use to orchestrate functionality and to simplify that orchestration. When we have a request or some bit of work that needs to be done, some unit of work, a lot of times we'll have requirements, and requirements fall into one of two buckets. Things that have to be successful now versus other. And other tends to fall into two other buckets. Must be successful eventually, or you can fire and forget it. Fire and forget it would be things like metrics or logging, where those systems are so stable that you have confidence they're going to succeed, and you're not going to handle errors. You're not even going to assume errors happen. We just log the errors and we're done. Must be successful now would fail the entire request, and must be successful eventually will have to eventually be successful, but it shouldn't fail the request if it fails at first. So that kind of falls in a weird bucket for many people. They don't know how to deal with these three very different types of things that need to happen when you're completing a requirement. I suggest that we use Ecto Multis, Oban, and transaction callbacks to accomplish the three different types of things that have to happen when you're fulfilling a request. So I'm going to do a very brief overview of Ecto Multis. Ecto Multis is a data structure where you can group a bunch of operations for the repo that need to execute at the same time. So you're able to pack a lot of stuff in there. We have API calls that will allow us to look at what's in there, and API calls to manage the object. I will warn you, multi-objects are opaque. You should not really know about what's inside. You should not be reaching in and handcrafting bits, okay? So you should always be using that multi-API. The multi-API gives lots of stuff to use to do that. So this is a sample of a multi. Here I'm inserting a user, and I'm also just putting a random key in there. I'm a random key of my variable, along with some value. And to take a look at what this looks like before you run the transaction, this is the type of object you have. You'll notice there are two important things that I want to call out. Three, actually. One, there's a list of operations. Operations are a list of items. They're a list of items that are key value pairs. And the names are a map set, meaning the names have to be unique. Clearly, if you had an operation that had the same name, like two operations with the same name, you're going to have a collision in that map set. So multis require unique names for each operation, and it stores the operations as a list, which implies order. And the third thing I want you to know is, even though you can see these things, you shall not reach into the multi and touch them. Use the API functions to handle all these things, because sometimes what prints out on the screen can be hard to you might think you understand more about the multi than what you do. Rely on those API functions before you shoot your foot off. Ecto Multi gives us a lot of operations that we can use that we're very familiar with. Like there are repo calls for repo.insert and repo.update. The same thing with multi. The main difference with multis is that you have to assign a name to the operation. There are other familiar operations that come with multi, like one, all, exists. All these things we're very familiar with seeing with repo that you also have with multi. And the key here is that they also need names because multi store everything by key value pair. Then we have a group of functions for multis that are really about managing the multi. Whether you want to look at it and call to list or inspect, or whether you want to create a new one or put a key value pair in, which we already saw. If you want to make it blow up automatically, add multi-air. That's always fun. And then merge, prepend, and append. These kind of link closely with the idea that operations are a list, an ordered list. You can imagine if you prepend a multi, the operations from one multi are going to go in front of the operations from the other multi. Or if you append, it's going to go after the operations. Merge is a little bit more, I find merge very helpful because you can look at all the results from the steps that have already executed in the multi for whatever step that you're currently in. So merge is really nice, and it kind of works along that same line. It looks at the results I've already executed, and that data is available to you. Now, on to my most hated Ecto multi function, which is run. And the reason why I don't like run are in orange down there, so you can just jump right to those if you want. It allows you to run an arbitrary function. Now, this seems like a massively flexible tool, but I call it a massively flexible foot gun. So there are some things about it. What I don't like about it is that it can create nested transactions, and it can execute side effects during the transaction that you can't roll back later. And that, I think, is the big thing that people don't think about. They don't think about the fact that during a run of a function, you might execute a side effect that you're trying to pull back. You've rolled back the transaction, but nope, those side effects are long gone. So let's take a look. We're going to start looking at a basic function, and we're going to talk about the different ways I propose to improve the function to isolate your responsibilities. This is a basic user function where we're going to create a user, and we're going to just get the change set and insert it in. There's no multis here. After we get it back, we are going to check and see how to do. And we're going to check that status. Now, when you take a pattern like this, what you end up with is that checking the status of the transaction happening constantly, all the way, all over your code. It's boilerplate that gets everywhere. Now, I hear you, Mr. Well, actually. You could also use a with. I get it. But the statement stands. You're going to have a lot of boilerplate that's copied from all over, and it's going to look the same. So I suggest in situations like this, where you want things to happen after the transaction, to use a transaction callback. Now, this is something new. I introduced this last year at DScout. And what this looks like is I added some functions to our repo module. And you can see on line 67 and on line 75 there, I have add transaction callback. Now, the main difference between them is that the function on line 67 does not require you to pass in a name. I suggest you always use the function on line 67, which only begs the question, why have I defined the function on line 75? For the purposes of this demo, I would like the callbacks to have names that are human readable. And so I've gone ahead and made them so. So I can pass in a name here. And what this is going to do, both functions do the same thing. It takes the multi and puts a key value pair in it. The requirements here are that the value must be a function. And if you care about error handling, this is probably not the right thing for you. Like if you care about error handling, if it's something more important than metrics and logging, using a callback is probably not the right tool to pick up. It needs to have a unique name, and I like to use the random generation for that. And I also, you have to namespace your callbacks so that when you get done executing the transaction, you can find the right things to execute. You can find all your callbacks. And also, this relies on transactions not being nested. And to nest transactions in multis usually comes with an Ecto multi-run. So as long as you're not using multi-run, you're saving yourself from a lot of possible problems. So let's go back to the function that I originally discussed, this create function where we're just doing a repo insert, and we're checking the results. And we're going to convert that over to using a transaction callback. So now what we have is we insert the user change set, we add a transaction callback for email, and we add a transaction callback for metrics. Now, you may say, why not just put them in the same callback? Well, you could, but I do like, for the purposes of this demo, having them separated out. Because for the purposes of this demo, we want to consider the email requirement a must happen eventually. It doesn't have to happen immediately, but it has to happen eventually. Whereas the metrics, we're just going to fire and forget. So this is great. We look at the multi after we've made it, and you can see we have a list of operations. We have our 2 callbacks in there that we're put in there. We have the user. Everything looks amazing. So now, how does the repo execute this? Well, what I've done is I've overridden transaction in my sample repo module. And so when I override this, what happens is I'm going to call to super immediately so that repo transaction can execute. And then I'm going to take a look at the results. So the next slide I'm going to show you is the results that are on line 22. Here what we have is it came back from that transaction, it has the user, and it has the 2 callbacks that we put in there. Great, the transaction worked, we have a user, the callbacks are still there. So now we're on to line 24. We're going to execute these callbacks. What does that look like? Well, we have execute callbacks defined on both lines 30 and 43. The reason for this is that you can use repo.transaction with both multis and just regular repo actions. So we don't want to try to iterate a struct. We only want to look at maps, and if it's a struct, we don't want to look at it, it's going to fall through, and we're just going to return it, because we can only put these callbacks on multis. And then what we're going to do is iterate over the key value pairs in the result set to see which one is namespaced with callback. Now here I've defined a variable, transaction callback key, but that's actually the string callback. So you're going to see that in the demo quite a bit. So when we get done executing callbacks, oh, another thing to look at here. I don't care. If you look at lines 47 through 53, I don't care if it's successful or not. I'm not going to let it blow up. I'm not going to be disaster girl. I'm not going to watch it burn. I'm just going to package it up and put it back in that thing and send it back home. Because remember, these should be fire and forget. They should be super stable things. So the result from this transaction will be a user with the callback email along with its result, and the callback metrics along with this result. This is great. We just moved a bunch of boilerplate in. We have a way of having callbacks to execute when you're successful. But there is a problem with this, and that is what happens if your callback email result happened to fail. Let's imagine you get a third-party failure for some reason. Well, we didn't fire, we need that to work eventually. And so this doesn't really fit as a great pattern for using a transaction callback, because I've already warned you, we don't want to handle these errors. We want these things to be really stable. So what do we use when that happens? Well, if we think back to our requirements, what we have are, there are things that have to be successful now, and then we have others. Fire and forget it can be those transaction callbacks. Awesome. And if you're wondering how I ended up on that present, it was like the first image I saw. So that just made it into demo. But then there are things that must be successful eventually. So I suggest we use Oban. And the reason why we want to use Oban is because Oban is a nice job queue. It will have workers that can process the jobs. It has mitigation strategies like retrying if something fails, or you can hook up alerting around it if you continually have a lot of fails. And so Oban provides us this way of making sure that something's successful eventually. But Oban also supports multi-inserts. Like you can do an oban.insert. If you hand it a multi as the first argument, it's going to actually create a job in the database jobs table that will get run by the workers. And if that transaction rolls back, that row gets rolled back as well. So it kind of gives you all the things you want. You're able to say, yes, this is going to happen, this is scheduled to happen. You have strategies within Oban to deal with failures, and then you don't have to worry so much. Like you can just take that whole piece of work and delegate it off to your worker, delegate it off to the piece of the system that knows how to make that work. So I had to go and install Oban. At work, it's just there. It was there before I got there because I work with Parker, and of course Parker's the author, so it's going to be there. But when I introduced it to my repo, it was super simple. One page of instructions, ran through it. At the end, you type in a command to figure out what your Oban config is, and voila, this is what I got out. So that was very easy, successful. Then I needed to make a sample, or my repo is called sample. I needed to make an email worker. And that email worker is just an Oban worker that sends that email for me. So now, when we take a look at something like this create function, now what I've done is I've replaced that add transaction callback for emails. I've replaced it with an Oban job. And this is nice and helpful because now the things that I can fire and forget are being fired and forgotten. The things that I need to track, I can track with Oban. And things that have to happen now are part of the multi-insert. So this is perfect. This multi, before you actually execute it, is going to look like this. And you'll notice that this is not quite as helpful anymore. We have this merge. Sometimes merge ends up in there in ways that you can't necessarily see what's in there. But if we look back at the code, we can kind of see it's the Oban job getting merged in. The reason I'm using merge here is because that user value that got inserted is important to me, and I need information from that user in order to do the next thing. So I'm using merge because merge gives me the results, and then I can use those results in whatever follows. So even if you're making 100 things above it, you have access to those things that you can wrap it all up in one transaction. So when we execute this, this is what we get. We get a user, and you'll also notice we get an Oban job. We get an email key with an Oban job down there. And so now our email is no longer a callback that we fire and forget. Now our email is a job that's in the database that we have some persistence on, and we have some way of mitigating if there are problems. Now is when it starts to really get fun, and holy smokes, I'm flying. I'm like way ahead. It's okay. That's totally fine. So what I like about this is now I can take my create function and I can break out my create multis function. And at first, it may not seem why this is really where the power lives. And the power lives here because now, if I'm creating an account and I need to create a user at the same time, I can reach in and grab this create multis. I can call create multis to get all my multis about how to create a user. And my accounts context doesn't have to know anything about how I create that user. It's going to get the user creation. It's going to get all the side effects from that user creation. And no other module has to think about the side effects that have to execute. It's all wrapped up very nicely. So you can imagine a situation where you might have to make an account, make several users, those type of things. You're going to be able to just reach in and grab to create user. Now, I know what someone's thinking, because someone's ahead of the game here, and they realize that if I use this create multis more than once, what's going to happen? Correct. I'm going to have a name collision because I have assigned the Atom user to this insert. Now, we've dealt with this at DScout because the user's context is very much like this. It's called from a lot of places, a lot of things are happening. And because of the fact that I can end up with multiple user updates and maybe have collision keys, I made my functions. I haven't done it for the purposes of this demo, but I did do it at work, which was I'm able to pass in options to my multi. And one of the options that I can pass in is a multi-key. And so that callers to the function can say, hey, I want you to name the user that I get out of this. And then I can put that in. And a lot of times what I'm using is some type of ID or maybe a random token there. Whenever I have name collision, there are ways to get around it. The function gets slightly more complex. But just know if you're trying to do something like this and you run into this wall, you're forewarned, although I'm not going to go into all those mitigation strategies now. It's relatively easy. You just pass in some options with that key in there, and you're off to the races. So this brings us back to the layers. When we put this in the functionality of the orchestration of functionality, what we're able to do is if all of our objects have this pattern of having a create function that can run the whole thing, or create multis that can just return you multis that you want to use to execute. Now when you're trying to put things together, you can have requirements that come in, like when I make a user, I need to make something else. And now making that something else is relatively easy. I just go grab its multis, put it in the multi, and I have very good tracking of when this is successful. All of these things absolutely happen. When this fails, none of these things absolutely happen. Because what you don't want to get is in a situation where you're looking at code and someone's like, well, what happened? You're like, well, possible 7 outcomes. That's the way, like, how do you debug that? If you have possibly 7 outcomes or 7 roads to run down, like, how far did it get? What really happened? And depending on how well you have instrumented your code, that can be really hard to get to. So you really want to have a function that when it executes, you know exactly what happened, and when it doesn't execute, you know exactly what didn't happen. So you're not left in this in-between state, because managing in-between states is a big mistake. Don't do it. So with orchestration, this functionality piece, that's how I'm going to use these multis. So here, what I have is a new business requirement. Product has come to me and said, you know, whenever a new user is created, we need a thing made. And I've been very, very creative here, and I'm calling it a thing. And you could imagine this making its way into the user's create multi-function. But now, the problem I have with this is now my user has to know about things, and it has to know about the side effect of those things. It has to know to insert the thing chain set, and it has to know that it needs to emit a metric that it created a thing. This is a problem for me because I like to think small, and I don't want to have to think about the whole world at once. So what I suggest is making a context for things doing your create function for things there, having your create multis for things there. And you can see now the things context knows what has to happen. What are the side effects that need to happen when I create a thing? And what this allows us to do, I'm sorry, like, work wants to update my computer at the worst possible times. Like, I'm sorry, I just, like, it won't stop. And I'm trying to, like, go through it. Now I can't even, I'm sorry. This is Keynote's gone. That's amazing. Keynote just shut down on me. Yay, we're back. Okay. All right. So now instead of having the users know, oh, when I create a thing, I have to insert the thing, and then I need to emit metrics, now all it's going to do is reach into the things context, call create multis, and it's going to get those multis back. It's going to add it to its multis, and now what do I have? I have orchestration of functionality without the users having to know all these stuff that has to happen when you make a thing. And so here we go into the whole multi-run stuff. The filters that execute right there are pretty, like, it's like, don't say that word, don't say that word, don't say, stuff, okay. All right, so here, this is for purposes of demonstration, we have requirements. We're gonna make this user, and then we want to create a thing, and we wanna create a what's a who's it. And then we're gonna do the other user things. Now, instead of using the append and merge functions, we're gonna use run. So we're actually going to be calling, you'll notice, things.create and what's-a-who's-it.create. So let's take a look at things, or what's-a-who's-it.create. This is just that very basic function we looked at immediately, where it's going to execute the transaction, and if it's successful, it's going to emit metrics. Now, my metrics provider here, all it does is log to the console. So when we actually see the output from this, know that when I do a metrics count, that is equivalent to an IO inspect. And I've made my account things do something very similar. It's following this new lovely pattern, but this lovely pattern is stuck into a multi-run. So it's not, now we have introduced a nested transaction, and you'll see that this has a transaction callback, but when create gets called, all of that's going to be run at once in the run. And if we look at this total function overall, I'm purposely making it blow up on line 40. On line 40, it's going to error. I'm making it error, so that's going to happen. Now, when I run this code, what I get is I get the side effect for the thing created, executed. The side effect for the what's who's it, executed. And then the whole thing rolled back. And so now what you have is you have lies and more lies. You have logs or metrics that are lying to you. They're saying things happened that didn't happen because they actually rolled back. And this is exactly what I'm trying to prevent with transaction callbacks. Transaction callbacks, when you don't nest things, when you don't use multi-run, they only execute on success. And so now you can trust your metrics and logging much more. So you vastly prefer to use something like this rather than multi-run, because when one of these fails, none of those transaction callbacks, none of those metrics are going to get emitted. And so you have a lot of confidence over when you run something, exactly what happened and exactly what didn't happen. So big caution on multi-runs. Now, patterns. Why would I make a pattern like this? We make patterns like this mostly because I'm trying to reduce how many things I have to decide in one single day. I get decision fatigue really bad. Like, don't ask me what I want for dinner. I do not want to decide that. Just tell me where we're going. So patterns provide code consistency, and that's great because then people can read code much easier and understand what's really supposed to be going on there. And strong patterns do mean less decisions. But they also give you a framework to make decisions in. Like, when we think about these particular things, I'm going to skip ahead real fast. When you're talking to a developer about what needs to happen here, we have things that must be successful now, things that must be successful eventually, and fire and forget-its. And so now when you're talking about a problem, you can start grouping all the things you're talking about into one of these buckets and know exactly the way to code around that. And that's the same reason why we have these layers. It's because we want people to know this is where we expect things to go. It's fewer decisions. If you are doing auth Z in a schema, that's a dead no. Do not do that. And there's no decision to make there. The only decision to make is like find someplace else to put it. So we're trying to reduce these type of decisions that people are having to make. So it also provides a common vocabulary when you're used to talking about things and providing reasons for why you've made certain design choices, why you do things at certain layers, or why you bucket things this way or that way. everyone kind of in your org will end up with a common vocabulary, and when they start talking about things, sometimes just saying words that mean the same thing to everyone solves the biggest problems. Crazy, I know. All right, let's see. So Melissa, head up here, baby. Okay, so I work with Melissa. Melissa's great. She got hired by D-Scout, I don't know, a year ago? Has it been a year yet, Melissa? 5 months. So she came, we had a process with a lot of developers in it, a lot of really great developers. And Melissa came out, she did a great job. And she was hired. And so when I got the opportunity to speak again, one of the things I like to do is to invite new speakers with me for 4 years, 3 years. Is Kate here? How many years did you do it? I can't read that from here. 2 years. You did it 3 years at least. I've shoved her on stage a lot, just trying to get her more comfortable. By the way, I have 2 daughters here, both over there. Avoid them if they're Spitfires. Okay, you're just in for more than you bargained for, because like I'm actually older and I get that I shouldn't say certain things. Them not so much. Okay, so Melissa's going to take over. She's going to talk. Okay, so I have a problem. I have her presentation up, but it's not showing yet. I think maybe I have to. So anyway, I want to encourage people that are speaking sometimes instead of doing a Q&A, because you can always find me outside, catch me outside. So instead of doing a Q&A, oftentimes if you are able to pull someone up on stage with you and give them an opportunity to present without fighting for a lightning talk slot, it's super helpful for everyone to just get used to it. Are you good? Yeah, so you just tap next, yeah. There you go.
Hello. Here we go. Hello, everyone. I'm so excited to be here. It's my first time coming to an ElixirConf in person, and I'm also nervous at the same time, since I've never imagined I'd be on this side of it, ever. But I come prepared, so I just want to chime in on Miki's talk about Ecto in general, and I've recently used Ecto window functions, and I found it a flexible way to group data, and I just want to share it with you guys. So let's get started. What is a window function? A window function performs calculations on a subset of rows or windows that are returned alongside the existing rows in a table. Here's what it looks like, where you see each individual row with a computed value next to it. This is helpful if you want to do more computations like getting percentages or have a running total, or even just to compare the current value with an overall value. With that said, let's see it in action. Here I have a sample table with the employee number, department name, salary, and let's try to get the average salary of each department. One way to do this is with an aggregate function. In this query, we group together the same department and compute their salary. It collapses all the rows from the table and gives you one single value for each group. Another way to do it is actually with Windows function, where instead of using a group by clause, you can just select the columns from your table and use a window function with a partition by clause. The results show the individual rows with the computed average. You can think of it as an inline version of the aggregate function, where instead of having to do a join, you'll have all the results in one query. So let's break it down. The SQL syntax includes the window function and then passing it the columns or expressions you want to use with the window function. An over clause defines the window where you want to use that window function on. Leaving it blank means it will run the function over the whole table, and having a partition by clause will divide the rows into multiple segments or windows where it would just apply the function over each segment. And here at the bottom portion of it is how you would do it, the same query in Ecto, where you just select the the column names and have an over function where you pass in the window function and a partition by expression. So in addition to the partition by, you can also use an order by clause where you sort the rows in your table. This is helpful if you want to do a ranking or a ranking function, basically. And then you can also pass in a frame clause where there are 3 modes to it, which are range, rows, and groups, and pass in values for the frame start and frame end and frame exclusion. The possible values for the frame start, frame end, and frame exclusion are unbounded preceding, which means you want to include the first row in your partition. Offset preceding means you want to include the X number of rows before the current row, including the current row, and X offset following means you want to include X number of rows, including the current row. And unbounded following means you want to include the last row in the partition. The frame clause is very powerful because you can actually create or to get more granular with your window function. Like in the screen, you will see that you can have it run the function only within a frame clause, like even though you have the bigger partition by. Yeah. So to recap, this is how we do it in Ecto. You have we can just pass in an over function and pass in the window function name and a partition by. Or in this second example, where we're using a name window called previous month, and we're using a frame clause that tells it to just run the average salary 3 rows ahead of the current row. Yeah. So I hope that next time you would need a window function, you can just use the built-in Ecto query. So thank you for your time, and I hope this has been helpful.